In previous videos, we've discussed which worlds would be the best to colonize with today's technology. Now we'll look ahead to the future and see what technology can help us terraform worlds and make them livable for humans. The following conditions are required for humans to survive on other planets. We've discussed these before. One is a magnetosphere, which protects us from cosmic rays and radioactivity from the sun. It also helps retain our atmosphere, as solar winds can strip it off over time. Whether it be natural or artificial, that is something we must have. Next up is a breathable atmosphere of mostly nitrogen, not oxygen. Oxygen being the main component of our atmosphere is a misconception, it is nitrogen. Number 3 is a normal air pressure, not too low like Mars or too high like Venus. Number 4 is gravity, or at least around 9.8 meters per second squared. It can be slightly higher or lower than that. Number 5 is liquid water. The temperature can't be too high where the water just boils or too low where it just stays frozen. It has to be in a liquid state. Number 6 is usable soil to grow food, so we don't have to constantly transport it from Earth or any other place that has soil to the location. And lastly, we have temperature. Like pressure, this cannot be too hot or cold. Now let's cover some potential or theoretical future technologies that could help us with these problems. Let's start with what I listed first, a magnetosphere. So to produce one, let's kind of go over the one for Earth. Our field is generated by a dynamo effect in Earth's core, where the convection of iron alloys produces Earth's geomagnetic field. For Mars, if we're still considering it at this point as a candidate, it turns out you can create a ring of charged particles around Mars thanks to its moon Phobos. So what would happen is that if we use Phobos by ionizing particles from its surface, we then accelerate them so they create a plasma torus or ring around the orbit of Phobos. This would create a magnetic field strong enough to protect a terraformed Mars. This method could effectively be repeated for any outer solar system moon or world that has another moon that's close enough to its orbit. For any other world that does not have a close moon or that isn't Mars, there is a project called the Ring Trap 1 or RT1 project. It's an experimental apparatus located in the University of Tokyo. What it does is that it takes a magnetically levitated superconducting coil and it basically has to create a planetary magnetosphere type dipole in the laboratory. So they use a vacuum vessel and that generates a magnetic field and that confines the plasma. This setup allows operation without any kind of mechanical structure, making it possible to generate plasma in an environment akin to that of a planetary magnetosphere, even within a ground-placed facility. So as this technology progresses, we'll be able to use it to protect colonies. To address the atmosphere problem, I'll borrow from the previous video and say that we can make genetic modifications to algae. We can improve photosynthetic efficiency, which can directly increase oxygen evolution. For instance, certain algae saw a 45% elevation in oxygen evolution. We also have O2 production plants. So the way that a O2 generator works is that it uses pressure swing absorption. So the generator consists of two separate pressure vessels filled with the material that separates the oxygen from the incoming air. At any time, one of these vessels produces oxygen while the other is regenerating. All we have to do is produce carbon dioxide, which we're definitely capable of doing, and the generator will separate the O2 out of it. One of the methods of doing that is using a laser to zap CO2 in a high energy vacuum using a UV laser, and it causes the bonds to break into O2 atoms. So then these same atoms can combine back into O2. One thing I didn't mention is basically the concept of going up to an asteroid, strapping a rocket to it, and then just navigating the asteroid using it as a spaceship and leading it to a planet or from a planet. Now, some of these meteorites or asteroids are very gas rich. So they'll have gases such as helium, neon, argon, krypton, and xenon. And those can help us basically fill the gases of a planet. Now, they don't have as much gases as you probably would hope for, but they can actually help us. And again, we can move the asteroids that have enough soil on them. Now, I'm using the term asteroid and meteorite interchangeably. They're not interchangeable. Asteroids are much larger, but for these purposes, I'm just saying strap a rocket to something and then fly it to another location. Now, the process of creating an atmosphere heavy enough would take centuries. And I'll actually address this issue in the next video. These videos so far have all been kind of companion videos, so if you've been watching so far, it will make sense to you. This same making a heavy atmosphere will also increase the air pressure, since the air pressure is correlated to how many gases are in the atmosphere. I imagine that we can build some kind of aircraft that will have lasers inside of it, and it'll fly around slowly converting CO2 into O2. So that covers the atmosphere portion. Our next topic is gravity. So other than rotating at a specific speed or accelerating a certain speed and maintaining it, how else can gravity be generated? So I'm going to be honest with you. Pretty much all these things I'm about to list are theoretical. No one's actually created something that can manipulate gravity so far. So one idea is to install an ultra high density core, and basically it would generate its own gravitational field and pull everything inside of it. However, an extremely large amount of mass is required to produce even a tiny gravitational field. For example, a large asteroid produces only several thousandths of the G, so the only practical way to do this is to find a very, very dense material and use that to take up a low volume of space. Long explanation short, we currently don't have anything to make this possible. Another way is for us to use an extraordinarily powerful magnet to implement some kind of artificial gravity system. Using diamagnetism right now, we can levitate a frog, implying that we can produce up to 1G. But this is accomplished using a magnetic system that weighs thousands of kilograms. It must be super cool using very extremely expensive cryogenics to keep it super conductive. This kind of technology might improve in the future, but as for now, being able to increase the gravity to Earth-like levels is not technology we have access to. It may exist by the year like 2100, but that's all I can really say for now. Sorry, I've told you this section to be kind of sparse. All right, so liquid water and temperature. I'll actually combine these two together. First off, we have desalination plants, which take water and remove sodium from it. So we can basically take seawater and turn it drinkable. The only problem with this is that it takes an extraordinary amount of energy, which is why we don't have a lot of this, but it does already exist. And I assume this will become more energy efficient and slightly less expensive as time goes on. The most common technologies for this uses reverse osmosis, and it has like a semi-permeable membrane. When under high pressure, it'll separate the sodium from the water. Another way to do this is to use heat to evaporate and condense the water, and you basically just leave the salt behind. For spatial water sources, there's Phobos, the moon of Mars, and several moons in the outer solar system are believed to have internal oceans. So there is plenty of water for us to have access to. We just use one of these methods, and you can use it to filter out other substances, chemicals, and materials that's not sodium. Sodium's not the only thing they can separate out, is what I'm saying. Now, remember what I said before. We want water in a liquid state. And other than Venus and Mercury, most worlds are too cold. Those two are the only real exceptions. Those are too warm most of the time. So in order to keep the water liquid, I did do some research and found that in China, back in 2006, they created a man-made star for 102 seconds. Now let's assume that this star's lifespan will expand and improve to hours, days, weeks, and possibly a few short years. So maybe up to 5 years or so at a time, we have to activate this sun, this artificial sun that we've created. But with a temperature that's 3 times hotter than the sun, depending on its size, this will allow us to warm entire satellites, Mars, or potentially habitable worlds in the outer solar system, including Ganymede and Titan. This would be very helpful in quickly melting ice into water. There's also heat generators that can generate heat using metal nanoparticles and electromagnetic radiation. It produces enough heat that it can melt ice. Another idea is to use a giant mirror to reflect sunlight and focus it to a point to melt ice, and possibly include greenhouse gases that we can definitely produce. Like I said before, with carbon dioxide, but there are other greenhouse gases, and they'll help retain the heat in the atmosphere once we get it going. Or we can use a mirror to reflect or block sunlight and make the area underneath the mirror cooler as well. This is something that I mentioned when I was talking about Venus. We had these reflective blimps, and basically they would reflect the sunlight back into space and cool the area underneath. Then there's the really out there hypothetical technologies like mass drivers we can use to send things into orbit, or potentially getting those ships I mentioned before. In concept, you get a ship converts the gas and flies to a different spot in space and then drops the gas off somewhere. So you would take maybe the CO2 from Venus and then move it to Mars. Yeah, and then if we ever had like portals, you can maybe open it up the portal from a high pressure spot to a low pressure spot. So from Venus to Mars, right? And then the two attempt to balance each other out. But that's just all hypothetical. So who knows how that technology would even work. Lastly, we have soil. We'd have to create compost for growing food. Now, there are asteroids that have carbon rich soil where scientists have grown lettuces, radishes, and chili peppers. So it is possible for us to grow it. We just have to make like some kind of sealed dome over the plants and then keep them warm as well as give them water. They should be able to grow food for us. There's some asteroids that have agricultural nutrients, including nitrogen, potassium, and phosphorus. Pure asteroid regolith is prone to compaction and crusting. And so to prevent droughts, we have to mix organic matter and peat moss or decaying plant material into the soil to retain the water and soil structure. Another alternative is that researchers have proposed converting organic compounds found in asteroids into edible food for astronauts. So basically, they would heat the compounds found without oxygen. This would break down the hydrocarbons into oils that are then fed to a bacteria, and they would produce a protein-rich biomass. The study suggests that a single asteroid could produce enough material to feed an astronaut for at least 600 years. They say up to 17,000 years. I'm not gonna claim that, but let's just roll with it, all right? Depending on the efficiency of the conversion process. So this could provide us with long-term food on deep space missions. So there we have it, all the terraforming technologies that would be helpful in modifying a world. Which one was your favorite? Let me know down below. In our next video, we'll take it a step further, and I'll show you a smart way to terraform a planet or world. Thanks for swinging on by, and I'll catch you guys all next time.